And what we do is we take off-the-shelf semiconductor chips that are very small, smaller than a pinhead. You can see the chip on the bottom right of this picture, about 500 microns in diameter. And here's another picture of an LED chip we use against grains of salt. If I was to put this chip on a table in front of you, or even on a white cloth, you probably wouldn't see it unless it was pointed out to you. And what we have to do is wire it up for a power supply, other communications, or an antenna. So we have to use a pick-and-place device, which is used in the electronics industry, with a digital microscope, and an infrared workflow station to solder the chip to the connecting elements. And here's a schematic of what we do. It's a bit out of date, but still we put the electronics into the core of the yarn. In that, in the image there, the brown fibres, the conducting ones, and they're shown on the outside, but in fact, with our latest developments, the conducting fibres run along the centre of the yarn. And as I said, this is our logo, and it shows a semiconductor chip embedded in the centre of a yarn. And here's an actual one where the chip has been wired up and protected by a resin micropod. And a resin micropod protects it in use and enables the resultant textile to be machine washed and tumble dried. The surrounding fibres there are not shown, ones which are used to make the yarns. And here's an example of some of the yarns with these integrated LED chips. We see that LEDs have some sort of use in, of course, electronic textiles, but we like them particularly because they're good to demonstrate. But of course, there's many other functions one could incorporate into yarns using this technology. And when we've put the electronics into the yarn, you can't really see it. This is a yarn containing a thermistor. Unless it's really pointed out to you, you can't see that yarn is any different to any other yarn. And we take the yarns and we test them, the stress strain, but also we've got ways of monitoring functionality. We want to see when the electrical functionality of the yarn fails, as that's very important. Another advantage of our technology is that you can use conventional textile equipment to make your fabrics from the electronic yarn. For example, you can use one of these computer-controlled flatbed knitting machines or weaving machines to integrate the smart yarns. And here's a top incorporating these LED yarns that we made for an exhibition at the Houses Department about 3 years ago. And there's two features that are important there, if you can see it, is one, the fabric is the same on both faces. It's no different. And if you just again switch off the LEDs, then you wouldn't be able to detect there's anything there, any electronics there, because all the electronics runs along the core of the yarn. And it has to be robust, and we're doing some of this work for the military, and that has to be particularly robust. And the student doing that made this cushion with LEDs incorporated in the fabric. By the way, it looks like we've embedded very large LEDs. It's just they're illuminating the yarns around them. They're these minute little tiny LEDs. And that cushion that he made has been to New Zealand, been to China, been to various exhibitions in the UK, and people have prodded and probed it, and it's still going. As another example of the robustness of the technology, with these micropods protecting the functioning elements, this piece of fabric's been machine washed and tumble dried, and it's still working. No problem at all. An important benefit of this technology is because the functionality goes into the yarns, the shear properties of the textiles are retained. And that's very important. It's one of the reasons you're wearing a textile. when a textile conforms to a shape, bits of it bend and bits of it go into shear. Paper bends, but it doesn't shear, so it won't conform. So if you put the electronics into the yarn, that shear property is retained, so that the yarns aren't locked in place. So that's another advantage of using this technology rather than some others. So what are the uses? Well, we think a lot of the uses haven't been thought up yet. Many are going to be failures, but I'll just go through some ideas, just scraping together a few ideas that we thought of a lot more. We've had a few brainstorming sessions. First of all, the obvious one is in fashion. You can buy, at the moment, LED garments for the stage and screen. Social interactions might be important when your garments flash when you meet someone with the same Facebook profile. Safety, perhaps for cyclists, or perhaps people who work at night on the roads and railways, that sort of thing. A whole host of applications for illuminated garments. And then in medicine and sports, this is Sindhu, our research student, who's integrated a thermistor into the armband and connected and set up Wi-Fi connectivity. So when he puts the armband on, then you can monitor his skin temperature on that laptop. This is an application we think might take off first. RFIDs. If you don't know about RFIDs, they're like barcodes but in chip form. And they're widely used in industry for tagging items, including textiles, and I believe there's a lecture, a presentation later on, either tomorrow or the day after, on RFIDs and textiles. But the advantage of putting it into the yarn, into the heart of a fabric, is people can't cut them out without destroying the fabric. So it will be very good for anti-counterfeiting and anti-theft. Of course, stock management, customer information, media zest to make a mirror, and if you stand in front of the mirror with an RFID in your clothing, in the label in that case, then the mirror will show the customer all about the garment, where it comes from, its green credentials, its price, everything like that. And of course, beyond that, monitoring the customer perhaps when they come back in the store, you know all about them. Or perhaps for the customer to organise their wardrobe. What did I wear with what, when? That sort of thing. And we're looking into it, using it in recycling. We thought, initially when we started the project, that the RFID would be used to sort out different fibres for recycling. Of course, what we didn't realise, in the UK, the major way of recycling is recycling garments. But even so, a charity like Oxfam will have a large conveyor belt manned by people that have got to sort out the garments for different markets. For instance, to a hot climate, you don't want to send all your woolly pulleys, that sort of thing. So they've got to sort that out, so we're doing a feasibility study to see how RFID can help in recycling. And as well, our Oxfam has told us, and this is the advantage of going to the customer very early on, they're interested in this sort of thing, to tell the donor about what happens to the garment and tell the recipient who the donor was. Another demonstration of the technology is this illuminated car seat. When you buy your next Rolls Royce, you'll have the option of buying an LED in the header. That's not using our technology, but you can see how this technology could be used for car lighting, or to change the colour of the seats, perhaps on a daily basis, or for signage, perhaps in the carpets and aircraft, indicating where the doors are. And I see some sort of future in composites. In not too many years in the future, cars, what is the cars are going to be made from composites, not metal. And if you could use a clear matrix with LEDs put in, perhaps you could change the colour of your car on a daily basis. Perhaps the fire engine could flash red as it whizzes past. Or quite a way in the future, this is interesting, perhaps you could put strain gauges into the yarns and use those yarns to make composites in something like aircraft engineering. Most modern aircraft these days, the fuselage is made from textile composites. So there's some advantage in, say, the wings, monitoring the strain history or the strain cycles over a lifetime. And we hope to move the technology on. At the moment we've got a slight problem. We take off-the-shelf chips. People don't make chips to go in yarns currently. So we're limited on the fineness of the yarns we can produce. So we teamed up with the electronics department at the University of Southampton, and we received a £2.8 million grant, whereby Southampton are going to make custom chips, smaller custom chips designed to go in yarns, to produce finer yarns with greater functionality, working towards eventually perhaps the textile computer, and all those applications. Another problem we've got is speed. We're producing yarns on a craft basis, but this is where we've got an automatic pick and place device, but that's designed to put electronic components onto a hard PCB. We've got to put a component to a sort of soft, fluffy yarn. So we've got to design all the sort of yarn feed systems and mechanisms to do that. But as for the prediction of growth in industry, consider if RFIDs did go into every textile product, the speed you'd have to do to produce that. And I think that's a long, long way off. But for early applications, niche markets, the methods we use at the moment are probably sufficient. If you want to learn about what we're doing on a weekly basis, then have a look at our Facebook page. You don't have to be a member of Facebook to see it. Just search NTU for Nottingham Trent University Advanced Textiles, and there you'll see a couple of videos of our technology in action. Okay, thank you very much.